All right, welcome everyone. We're back at it after a day away, and we're through with the math for the most part for a little while until we get through with this particular chapter. Today we're looking at Intro to Sampling, and we're going to work a little bit more with a random digit table. We pretty much know how it works, so I'm going to skip over a lot of it. Now, since there's not a whole lot to show you necessarily, then I'm just going to go ahead and sort of highlight things. You know, if I'm going too quick for how you write, you'll need to pause. So starting with, this is what we're headed for. This is where everything kind of ends up at inferential statistics. Unfortunately, we're not going to hit that until the beginning of next semester. So after this chapter, we're going to be hitting some probability, 3 units of probability. Most kids don't like that, but that's what we're going to do. Hang in there, though. Don't just bail on me, because inference is pretty great, and it's really pretty much the reason why we're doing all of this. But this is just the process of getting conclusions about the nature of a population based on data from a sample. So, given that populations are just too big in most cases for us to try to measure all the individuals individually, we're just going to, instead of give up our pursuit of knowledge, we're going to do an end around by skipping checking the population, just getting information from a sample from it, and then trying to infer back, which is kind of the way stats works. Now, there's 2 kinds of studies we're going to look at in, let's call it methods of research. That we're going to look at in this chapter. One is a study and one is an experiment. And for study, we can probably add observational to this, observational study. And it's a very passive thing for the researcher. You're there in the environment, but you've got your clipboard and maybe your stopwatch if you're timing runners. They run, you time them, you write it down, you report on what you saw. You're not imposing any kind of special diet on them. You're not having more sleep than others. You know, you're just there taking notes, all right? An experiment, however, is more active for you as a researcher, because what you're going to do here is actually impose a treatment on individuals in order to observe their responses. So you may have one group reading just the way kids are always taught to read, and then you have another group that's taught with some new method, so you're imposing the method of reading. And at the end of it, you measure their reading skills to see if there's any improvement with the new method. Sometimes there may be, like, not an improvement, but they could actually be developing more slowly. But you as a researcher are more active in this process. You impose the treatment. You step back and see what kind of response you get from that treatment. This is kind of important because we're actually due for a new national census in 2020. It's in the Constitution. We have to take a head count of everyone. And what could go wrong with that? I mean, when it was first instituted, when the Constitution was written, there was 17.5 million Americans. Now there's over 300 million. So if we're going to try to attempt to contact every individual in the entire population, my guess is we won't get all of them, no matter what we do. Now remember, a population is an entire group of individuals that we want information about. You can have really tiny populations, like for endangered species, you could have 10. But for most of what we cover, we're going to have big populations. Whoops, that went away. There it is. Now, this is what we were talking about. A census suffers from undercoverage. It is not possible to contact all persons in a large population. So who could be left out? How about this list? Homeless people, illegal immigrants, they won't be counted. Just people who refuse to answer, they're out there. Anybody who just can't be contacted is going to be left off. And if you think about it, don't we allocate representatives based on population for Congress? And don't we also send out money from the federal government based on population? So having an incorrect census is a real problem. There was a movement at one point to try to replace doing a census with sampling instead, and there's a lot that you can say about that positively. I mean, sampling is a pretty much developed science, and well, you've got to change the Constitution in order to do that. So we're still trying to count them all one at a time. So here's a term, sample. It's a part of the population we actually examine in order to gather information. So we can study a portion of a population to get information about an entire population. We just want to make sure that as we pick this sample, that we do it in a way that it represents the population as much as possible. Because if you want results from a sample to generalize back to the population, then that sample has to be like a mini snapshot of that population. If it's not, then your results probably won't generalize. So your job is to make sure sampling techniques and methods are chosen and executed properly. You'll see. All right, no need to write this down. Your population, let's say you're interested in some aspect of all parents of Cinco Ranch High School students. So you decide just to grab a sample of the parents who attend open house, make that your sample. And my question to the class was, is this an accurate reflection of all parents of Cinco Ranch High School students? And it was pretty much all agreed upon that it isn't. I mean, you've got parents that are maybe a little bit more uber involved. Maybe they have more money so that they haven't been working all day and they're dead tired and can't make it. But whatever that it is, I'm not thinking that these parents attending open house are necessarily going to be reflective of all parents of Cinco Ranch High School students. All right, a sampling design is a method for choosing the sample. Some are good and some are not so good. I'm going to use this word defensible quite a lot, all right? If you're going to conduct research, you're going to want to make sure it's good research. And you're going to want to make sure it's well done, and that if somebody calls something into question, that you can defend what you did. Because, if you're doing research, then there's going to be people reading it. And sometimes people reading it are also experts in the field, and they can be mighty rough on you to where they can destroy your professional reputation, and you don't want that. I mean, if you're doing something that you feel funny about, but you don't have any other choice, don't hide it, just say so. And, just say, hey, that was the best I could do given circumstances A, B, C, whatever. But whatever you do, make this all defensible. All right, bias is another term that we need, and this is bad. This is where, and it doesn't say you, but it should say you systematically favor certain outcomes. That's not right. You should just be recording outcomes, not making them happen. So if you are making them happen, then you're creating bias. And bias, it shows up a lot in the course in various contexts. Just remember, a shorthand for biased is missing the mark. Like you aim for something and you're way off, all right? In this case, some parts of your population end up being favored over others. And the reason for that is not all subjects have the same chance to be picked. That's not good, because if you're leaving people out, you may be systematically leaving out characteristics from those people that matter, all right? So bias is found in the sampling method, and since you choose that, that's your fault. All right, so sampling methods that tend to over or underemphasize some characteristic of populations will be biased, all right? All right, here is our first sampling technique. And you notice it says biased, so it's not good. So we're going to start out with two that are not good, and then we're going to move into one that is. And we're just going to cover one that's good and then do the rest tomorrow. So a voluntary response is when people choose themselves by responding to a general appeal, like a phone poll, which is a little archaic, but like an internet poll. And the problem that you run into is that most people look at those things and go, meh. They might answer them, they might not, but people with strong opinions are going to jump on those. And so that's what you're going to see. They're going to be overrepresented with probably an unfavorable opinion. So what happens is that the respondents, rather than the researcher, decide who will be in the sample. Again, that's not good. Now here's another one, convenience sample, that is also biased. All right, this is when you just grab anybody that's there. You don't really make any effort to selectively grab people. It's just like, okay, you're near me, come here, I want to ask you a bunch of questions. Like mall shoppers and pollsters. Well, if there's somebody doing a poll or a survey in a mall, they're not going to get me because I don't like the mall. I don't go there. And when I do go there, if I ever do, it's boring and I can't wait to leave. So they're not going to get me. But I don't know why that did that. Suppose that people that go to the mall just happen to be a little richer than those people who don't. And so you're leaving out a good variety of incomes because of the people that happen to be there. So you're going to see undercoverage. Remember you saw that for your census? It's here for your convenience samples. So you're just going to miss getting a good cross subject section of subjects. You're going to set up shop where people of a certain nature tend to be and other persuasions aren't. And that's not a good cross section. All right, look, there is always error in sampling. And in case you don't believe that, sampling errors cannot be avoided. So it's not a perfect science. It's flawed, and we're just going to find ways to minimize the flaws because we still need to know things. All right, one error source is random sampling error, and that's just due to dumb luck. So let's just say I need a sample and I need it to reflect that there's half men and half women, right? If I just randomly pick people, could it be that I will get 70% men and 20% women just by chance alone? You know, it's not likely that that would happen, but it can happen. So when that happens, there isn't a whole lot you can do about it. You just have natural variation occurring from one sample to the next. And yeah, so if you're trying to measure the speed of people to get some kind of average speed, and you just happen to pick randomly a whole bunch of slow people, you know, then you're going to get results and you're going to think, oh, people in general are slow. But that's not the case. All right, sampling method bias. All right, this is your fault if you're doing it. This is bias that occurs because of the choice of a sampling method. So if you do either voluntary response or convenience, you're throwing bias into your results, and that's on you. But could the people responding to you be a source of bias? Like, could you ask them a question and could they lie to you? Or could they not take it seriously and fill in all C? Or could they just be older and just be forgetful and just provide information that's not accurate just because they're elderly? This all is non-sampling bias. This occurs in the responses by the individuals in your sample. Now, you can come up with clever ways around a lot of this, but this is tough. This is hard. Because people are people and they will do what they want. All right? So error up here is okay. I mean, it's just built into the system. But bias is bad. You know, there's things you can do to try to lessen it. And by the way, that business of random sampling error with the men and the women, there is a way to defeat that problem, and we'll talk about that tomorrow. All right, so good sampling. Everything that I'm going to do from now on, the rest of this and into tomorrow, will be probability sampling. And this is going to utilize some form of random selection. So if it's random, it's going to take you out of the picture. And so, you know, it's just going to use chance to pick your sample, and that's about as defensible as you can make it. So the idea is to give each individual in the population the same chance of being picked. So that's the key feature of all probability sampling, is to give each individual in the population the same chance to be selected. All right. Now these break down into different kinds of probability samples. So when that happens, I will tell you what about it will distinguish it from any other kind of probability sample. But keep in mind that this second bulleted point will be the key feature. Somewhere in the process, you are going to give everybody the same chance to be picked. So everything from here on in is probability sampling. All right. So your sample is chosen. Oh wait, back to here. This is the first one, simple random sampling. Got ahead of myself. Or SRS for short. That's an acronym you can use. So if I say, let's do an SRS, that should tell you simple random sample. Okay. Now I'm not even looking at it, and I know it's a probability sample, so it gives everybody in the population the same chance to be picked. But specifically, your sample is chosen in such a way that every set n of size n individuals has an equal chance to be picked. So if I need in the classroom to pick 5 kids, then the first 5 are as equally likely as the last 5, or any combination of 5 kids somewhere in between. All of them are equally likely to be picked. Now we can do it using a calculator. We will do random digit table to finalize what we're going over now. But let's just say I have moon, heart, face, cloud. I want a sample of size 2. If I do a simple random sample, then the moon and the heart have the same chance of being picked as the moon and the cloud, or the cloud and the heart, or the face and the heart, or the heart and the cloud. You get the idea. So all of these possible pairings are equally likely to occur. And I'll just be picking one of them. So all possible samples of size 2 have the same chance to be picked. All right, we have talked about random digit table. I hope you're all familiar with it. I just want to highlight this idea of independence. So if you are in your random digit table and you see a 4, well, that doesn't mean the number next to it will definitely be a 5. In fact, you don't know what it's going to be. All right. When that happens, then all the numbers in there are independent, right? So independence more formally, and it's another term like bias, it shows up throughout the course in various places. And all you got to remember is knowing one outcome gives you no information about the next. So picture this. You have a full deck of cards. There's 26 red, 26 white. So if they're shuffled up and you pick one without looking, you have an equal shot at a red or a black, right? Did I say red and white? It's red and black. Okay, if you leave that red card out, then I can suddenly say, hey, if you pick again, you have a little bit better chance of picking black. If I can say that, your independence is gone, okay? If you put the red card back in, then you're back to independence because everything is 50-50 and I don't know at all what could possibly come next. All right, so that's how you look at independence. This is a term, sampling frame. You actually saw this term back in the earlier slide with the face and the heart and the cloud and whatnot. This is just the list of individuals from which a sample is actually selected. So if I'm interested in a sample of the kids at Cinco Ranch High School, I need a list of all of them. If I just want the juniors, then I need a list of the juniors. Okay? So those would be your sampling frames. All right, we know how to use a random digit table. So I'm going to pause for a moment and get set up for the second part of this. So please stand by. All right, I'm back, and we're going to select a simple random sample. We're going to select 7 of these 21 individuals, and actually these are students I taught in my last year at Katy High School. It was my first AP statistics class, so these are real kids. Well, they're not kids anymore. They probably have kids of their own at this point. But we want 7 of these 21 individuals, and we're going to go to line 117. Now I am not going to use my pen. I'm just going to use that to indicate who I picked. And I'm going to use a random digit table, which is here. And I can't mark this up. All right, so we're on line 117. That's here. And so get out your random digit table. Remember, it's at the end of your packet. All right? So let's go ahead and we'll do our best without me circling a bunch of stuff. So looking at line 117, your first number, two-digit number. Oh, let me go back to the numbering before we start this, okay? All right, if you'll notice, I went ahead and numbered all of these 21. And unlike when we did simulations, I did not start with 0. All right, when you do a simulation, you have to start with 0. You have to, right? It's either a 0 or 2 zeros or triple 0. It depends on how many things that you need to define using digits. But here, for Mark up through Jonathan, I could have done 10 through 31 or 20 through 41. All right. It doesn't matter, just so long as you've assigned digits. And since there are over 10 of them, or over 9 actually, I do need two-digit numbers. You could put all three-digit numbers if you want, but why? It would just create more problems. So I am going to start all of my sample selections, starting with 0, 1 rather than 0, 0. Not to make you can start with 0, 0, but I will probably actually tell you where to start so that we all end up with the same answers. So anyway, that's something to consider. And back to this. All right, so 38 was the first pair that we selected from line 117. That is not on our list. It goes up to 21 and no further. But then you've got 16. All right, there is a subject with the number 16. That is going to be Julie. Julie is in. All right? So let's go back. Now the 7 and the 9 are going to cross over this big chasm here. So that's 79, that's too much. Then 85, 32, 62, and there's 18. All right? So let's find out who 18 is. 18 is Krishna. So Krishna is in. All right, now the question comes, what if you get another 18? Like, do you pick Krishna twice? Well, you could if Krishna could become two different people. You need 7 total, and if you pick Krishna twice, then you're only going to get 6. So just ignore any repeats, all right? So then you have 37, too much, but then you have 06. Well, it is 06. So I'm going to go back, and 06 is Kristen. So Kristen is in. That's 3 out of 7. All right. So 32 is too much. 23, 41, 72, 61, 85, 41, 44, 87, 55, 32. All of those are beyond the digits we assigned. So come down to 118, but don't use 118. 73 is the first one, too big, but 19 isn't. So number 19 is in. That is going to be Lewis. Lewis, you made the cut. So we need 3 more. All right. Then we have a 03. 03 is in. So 03 is Adam. Adam is in. So that's 5. We need 2 more. All right. So let's see. 118. Let's see. That one. 04. 04 was Adam, right? So let's make sure. No, 04 is Catherine. Catherine is in. All right. So let's see. We have 40 and then 02. So 02 is part of it. So we have 4 here, 3 here. There is your simple random sample of 7 from 21 individuals. That's how it works. All right. So any group of 7 out of this list has an equal chance of being picked, just like those 7. It's just those are the 7 that ended up being picked. So there you have it. 2 of the sampling methods were bias, that was convenience, and what was the other one? Convenient voluntary response. Both of them, one created under coverage, one had opinions. You didn't get a good cross section because you were getting opinions from people who felt strongly about a subject. So you got to do the probability sample. That gives everybody the same chance to be picked. In this case, a simple random sample gives all possible sample sizes of n, whatever n happens to be, the same chance to be picked. So there you have it. We'll do more of this tomorrow. Until then, I'm going to bid you a fond good evening, and we'll pick this up tomorrow.